Welcome to The Explainer. Right now, as you're watching this, there's this incredible magic trick happening inside your computer. It's a constant, super high-speed juggling act that makes literally everything you do possible. So today, we're going to pull back the curtain on this unseen hero of computing, and it all starts with a pretty simple question. It seems pretty basic, right? We just expect our phones and laptops to multitask. But have you ever really stopped to think about how that works? I mean, how can a single processor do all these different things at what feels like the exact same moment and make it all look so smooth? Well, the answer reveals something you probably wouldn't expect. So here's the paradox. The very heart of your computer, the CPU, is no master multitasker. In fact, it's the total opposite. At its core, it only does one thing at a time, following this incredibly simple, repetitive recipe. You can think of it like a baker who's just focused on one single step of making a cake at any given moment. And this is its entire recipe. It's called the fetch-execute cycle. The CPU fetches one instruction from memory, it decodes what that instruction means, and then it executes it. Add two numbers, move a piece of data, change the color of a pixel, and then it just does it again and again, billions of times a second. Fetch, decode, execute. That is its whole world. Okay, so if the CPU is just laser-focused on that one recipe, what happens when something unexpected needs its attention? Like you click the mouse, or a new email just arrived. This is the doorbell ringing while our baker is busy mixing the batter. The recipe says nothing about doorbells. Something has to break the routine. And that something is the key to this whole explainer. It's called an interrupt, and it's exactly what it sounds like. It's a signal, a little tap on the CPU's shoulder that says, hey, stop what you're doing, something important just happened that needs you. It's how the outside world, everything from your keyboard to the internet, actually gets the CPU's attention. And these doorbells are ringing constantly. I mean, all the time. Every single time you click your mouse, that's an interrupt. You press a key on your keyboard. Yep, another interrupt. A new chunk of data comes in from your Wi-Fi. Interrupt. Even software does it, like when a program crashes or the system's internal clock just needs to tick forward. But here's the big problem, right? If the CPU just dropped what it was doing every time an interrupt came in, it would be total chaos. Our baker would just leave the oven door wide open and the cake would be ruined. So how does it handle these constant interruptions without your whole system just crashing? Well, the answer is, it's not chaos at all. It's actually a super disciplined, really elegant protocol, a precise set of rules that lets it pause its work perfectly, go handle the interruption, and then come right back. And that word protocol is key. This isn't random. It is an absolute masterpiece of engineering. So here's the protocol in a nutshell. First, the CPU finishes the exact instruction it's working on. It doesn't stop halfway. Then it checks how important this new interrupt is. Now, this next part is critical. It saves its entire current state, all its work in progress, to a safe spot in memory called the stack. Only after all that does it load up the new instructions to handle whatever just happened. And that priority check, it is absolutely vital. I mean, think about it. If the fire alarm goes off at the same time the mailman rings your doorbell, you're going to deal with the fire first, right? It's the same for the CPU. A power is about to fail signal is a huge priority. A notification that your music app finished a background task, that's super low priority. The CPU always handles the most urgent thing first. So with its main job safely paused, the CPU runs a special little program. It's called an interrupt service routine, or ISR. And you can just think of it as a specific mini recipe for each type of interrupt. For a mouse click, the ISR's job is just to figure out where you clicked and tell the operating system. It's our baker quickly signing for the package at the door before getting back to work. As soon as that ISR is finished, the package is signed, the click is registered, the interruption is officially handled. Now it's trying to get back to the cake, which has been sitting there perfectly preserved. And this is the final piece of the magic. The CPU just goes back to that safe place, the stack, and it restores everything exactly as it was. All its data, the next instruction it was about to fetch, it's all put back. It pulls the ingredients back onto the counter and just resumes the main recipe as if nothing ever happened. And the part that's just mind-blowing is the scale of this. This whole dance, this pausing, saving, handling, and resuming, It isn't happening once or twice a second. It's happening hundreds of thousands of times, every single second, inside the device you're watching this on right now. So, here's the big takeaway. Your computer isn't actually multitasking. It's an unbelievably fast single tasker that's just switching between jobs so quickly that it creates this flawless illusion. It's this constant, elegant dance of interruption and return that makes you feel like you are doing everything all at once. It's a really powerful idea when you stop and think about it. What we experience as a smooth, seamless reality is actually a carefully constructed illusion, built on this foundation of incredibly fast, simple, and disciplined little steps. And it really makes you wonder, now that we've totally mastered this illusion, what's the next great sleight of hand that computing has in store for us? What's the next impossible thing they're going to make feel totally ordinary?